Hello students, I hope you all are good. We are going to start with a new session of areas related to circles. Before that, let us see the learning outcomes of this session. Introduction and definitions related to the sector of the circle, area of the sector of the circle, definitions of arc and segment of the circle, length of the arc of the circle and area of the segment of the circle. So, let us start with sector of the circle. The portion or the part of the circular region enclosed by two radii and the corresponding arc is called the sector of the circle. So, these two are the radii OP and OQ, and this portion is the sector and this is the minor sector. The other portion is called the major sector. This is the major sector. As you can see in a pizza, the one piece of the pizza what you eat is the sector of the circle. So, let us move forward. The angle of the sector. What is the angle of the sector? If this is the sector, then this is the angle of the sector. We can name this as angle A. So, OPQR is the minor sector and angle A is the angle of the sector. Similarly, OPSR, this is the major sector and the angle of this major sector is 360 degree minus angle A. So, let us move forward. What is the area of the sector of the circle? Since this is the circle and this is the sector of the circle, we can say this is angle theta. Then area of the circle we already know, that is pi r square. So, area of the sector of angle theta, this is angle theta. The area of this sector will be given by theta divided by 360 degree into pi r square. Similarly, area of the major sector is this portion, wherein the angle is 360 degree minus theta. So, the area will be 360 degree minus theta divided by 360 into pi r square. So, let us move forward. Arc of the sector. This is the arc. Let us see in a circle. If we find a circle and this as the sector of the circle with angle theta, then the portion of the circle which is in the sector is called the arc length or the arc length of the sector of the circle. So, let us move forward. The length of the arc of the circle. Now, let us find what is the length of the circle. The length of the circle will be, this is the circle and this is the length of the circle. Then this length will be given by, the length of the circle will be given by theta divided by 360 into 2 pi r. What is 2 pi r? 2 pi r is the circumference. It is the circumference of the circle. Circumference of the circle is 2 pi r. So, the length of the arc of the sector is theta, that is the angle of the sector, divided by 360 into 2 pi r. So, find the area of the sector of the circle with radius 4 centimeter and of angle 30 degree. Also, find the area of the corresponding major sector using pi as 3.14. According to the question, we are given a sector OAPB. OAPB. This is the sector with angle theta as 30 degree. Then we know the area of the sector can be given as theta divided by 360 into pi r square. Substituting the value of theta as 30 degree, pi as 3.14 and radius as 4 into 4, we have, after calculating, 12.56 divided by 3 centimeter square. Simplifying again, we have 4.19 centimeter square. Now, area of the sector as we have calculated is 4.19 centimeter square. Area of the corresponding major sector, this is the major sector, right? Then this area will be pi r square, that is the area of the complete circle minus area of the sector OAPB. We know area of the sector is 4.19. This is the area of the sector, and pi r square is, pi is as given in the question 3.14 and radius is 4. So, r square is 16. Substituting the values and solving it, we have 46.05 centimeter square. Calculating it further, we have 46.1 centimeter square. Let us move to our next question. Find the area of the sector of the circle with radius 6 centimeter if angle of the sector is 60 degree. Here the angle of the sector is given as 60 degrees. So, let me draw a circle. This is the circle and we have a sector wherein the angle is given as 60 degree. This is the center O. Now, given the radius of the sector is 6 centimeter, radius is 6 centimeter and theta is given as 60 degree. Then area of the sector is given by pi r square into theta divided by 360. Substituting all the values, we have pi as 22/7, radius as 6 and theta as 60 degree. Substituting and calculating further, we have the value as 18.86 centimeter square. So, I hope this question is clear. Let us move forward. Find the area of the quadrant of a circle whose circumference is 22 centimeter. So, the word quadrant, what is a quadrant? If this is a circle, right, then the circle is divided into 4 quadrants, quadrant 1, 2, 3 and 4, and the angle in each quadrant is 90 degree. So, let us move over to the question. Let the radius of the circle be r. The circumference of the circle is given by 2 pi r. According to the question, here the circumference is given as 22 centimeter. So, 2 pi r is equal to 22 centimeter. Let us substitute the value of 2 pi r. 2 pi is 22/7 and r is given as r. Then, keeping r on the left hand side and all the numerical values on the right, we have r as 7/2 centimeter. Then, the area of the quadrant of the circle. Now, we know that the quadrant of the circle is also a sector of the circle. So, the formula will be pi r square theta divided by 360 degree. Now, substituting the value of pi as 22/7, radius r as 7/2 and theta as 90 degree, because in a quadrant the theta, the angle is 90 degree. Substituting all the values and solving it further, we have 77/8 centimeter square as the area of the quadrant. I hope this is clear. The length of the minute hand of the clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Here again we have a minute hand means a wall clock, right. Here we have a clock and we know this is approximately 5 minutes. Then this is angle theta and the minute hand is 14 centimeter. We want to know this is 5 minutes. We want to know the area swept by the minute hand. The angle described by the minute hand in 60 minutes, is 360 degree. Then angle described by the minute hand in 5 minutes, this is what we want, 5 minutes will be 360 degree into 5 divided by 60, that is 30 degree. So, here the theta will be 30 degree. Now, we have theta as 30 degree and radius r as the length of the minute hand is 14 centimeter. Therefore, area required, that is swept by the minute hand in 5 minutes, will be area of the sector with radius 14 centimeter and theta 30 centimeter. Again, the formula will be pi r square theta divided by 360 degree. Again substituting the values, we have pi as 22 by 7, radius as 14 and theta as 30 degree. Calculating it further, the area comes out to be 51.33 centimeters square. I hope this is clear now. Let us move forward. Segment of a circle. Now, what is a segment of a circle? The portion or part of the circle enclosed between a chord and the corresponding arc is called the segment. So, we have two segments, the minor segment, this is the minor segment, the smaller one, and the major segment, the bigger one. So, PQ, this is the minor segment, and PQ, this one, let me name it as A, then PAQ is the major segment. I hope this is clear. So, let us move forward. Area of the segment of the circle. We are going to start with the area. Area of the segment APB. This is APB. Okay. So, the area of the sector, this is AOB. This is the sector, right. So, area of the segment APB will be area of the sector OAPB minus area of this triangle. This is the triangle, right. So, we have area of APB segment as area of sector AOBP minus this triangle AOB. Okay. And we know area of the sector is given by theta divided by 360 into pi r square, and rest is just finding the area of the triangle. Okay. So, let us move forward. Find the area of the segment AYB shown in the figure if radius of the circle is 21 centimeter and angle AOB is 120 degree. We need to use pi as 22 by 7. So, this is the figure. We have, this is a circle with center O and AOBY, this is the sector, AYB, this is the segment, and the triangle is AOB. So, area of the segment AYB is given as area of the sector AOYB, this complete sector, minus the area of the triangle, this is the triangle AOB. Now, let us first find the area of the sector. We have already done that. The formula is theta by 360 into pi into r into r. Substituting and calculating, we have 462 centimeters square. This is the area of the complete sector. Now, for finding the area of the triangle, that is triangle OAB, what we need is, we draw a perpendicular OM. This is a perpendicular OM on AB from O. Then we have OA is equal to OB. Why? OA is equal to OB because each is 21 centimeter. Each is the radius of the circle. Therefore, by RHS congruency, what we have is triangle AMO is congruent to triangle BMO. This triangle is congruent to this triangle. These two triangles are congruent. So, let us move forward. Since M is the midpoint, here again M is the midpoint. So, angle AOM, this angle will be equal to this angle. Also, we know that AO is equal to BO. So, this angle will equal to this, and each angle will be 60 degree. Okay? So, let us take OM as x centimeter, the length of OM as x centimeter. Then triangle OMA, this one, OM divided by OA will be cos theta. Substituting the value, we have OM as x centimeter, this is x centimeter, and OA is the radius of the circle, so 21 centimeter, and value of cos theta, we know that cos 60 is 1 by 2. So, we have 1 by 2. So, the value of x comes out to be 21 by 2. This is OM. OM is 21 by 2 centimeter. We also know in the same triangle AM upon A will be sine 60 degree, and we know the value of sine 60 is root 3 by 2. So, AM will be 21 root 3 divided by 2. So, let us move forward. We have area of triangle OAB as half base into height, right? And what is base? Base is AB. AB is the base and OM is the height. We have already calculated the length of AB as well as OM. Now, AB is 21 root 3, substituting the value, and OM is 21 by 2. Now, calculating all this, we have area of the triangle OAB as 441 root 3 divided by 4. Therefore, area of the segment AYB. What will be the area of the segment? Area of the segment will be area of the sector minus the area of the triangle. Area of the complete sector minus the area of the triangle. We have both now. So, 462 minus 441 root 3 divided by 4. Calculating it further, we have 21 by 4 as common and 88 minus 21 root 3 centimeter square. I hope this is clear. Now, let us move forward. A chord of a circle of radius 15 centimeter subtends an angle of 60 degree at the center. Find the areas of the corresponding minor and major segments of the circle. Here we use pi as 3.14 and root 3 as 1.73. Radius of the circle is 15 centimeter. Area subtended by the chord at the center will be 60 degree. Area of the sector, we know the area of the sector is pi r square theta divided by 360. Substituting the value, you just need to substitute. We have pi as 3.14, it is given in the question, and radius as 15 into 15, theta as 60 degree divided by 360. Calculating it further, we have 117.75 centimeter square. Now, what we have to find is area of the triangle. Again, a shortcut, area of the triangle is 1 by 2 r square sine theta. Again, you just need to substitute the values. 1 by 2 r square is 15 square and theta is 60 degree. So, sine 60. We know that what is the value of sine 60? It is root 3 by 2. Calculating it all, we have 97.31 centimeters square. Now, we have to find the area of the minor segment. What is the area of the minor segment? Area of the sector minus the area of the triangle formed. So, this is the area of the sector and this is the area of the triangles. Subtracting both, we have 20.44 centimeters square as the area of the minor segment. What is the area of the major segment now? Area of the circle minus the area of the minor segment. So, area of the major segment will be 706.5 minus 20.44. Calculating this further, we have 686.06 centimeters square. I hope this is clear. Let us summarize the whole session. In this session, we have studied about the sector of the circle. This is the sector of the circle. Finding the area of the sector of the circle, the arc of the circle, this is the arc of the circle. Then the segment of the circle, this is the segment of the circle. Also, we also have found the area of the segment of the circle. I hope all the concepts are clear to you. Thank you.